So we're going to look at some of the main topics in chapter 3, looking at angles, in polygons, properties of triangles and angles and congruency. So we're going to work out the size of an interior angle of a regular 24-sided polygon. So if I draw part of a polygon here, so I've got an interior angle here, and if I extend each of my sides like so, going around in the same way like a bicycle spoke, so enlarging, extending each line, then that there is an exterior angle, and this inside one here is an interior angle, int for short and x for short. Now an interior plus an exterior angle add up to make a put together to make a straight line, so the sum of their angles is 180 degrees. And we know that the sum of exterior angles is 360 degrees. So therefore, if we know we've got 24 sides, then the exterior angle, one exterior angle, is going to be 360 divided by 24, which is 15 degrees, and therefore one interior angle is going to be 180 minus 15 degrees, which will give us 165 degrees. That would be method 1. We have a second method, so we know the sum of interior angles can be found using a rule, which is n minus 2 multiplied by 180. So our sum of interior angles is n minus 2 multiplied by 180, where n is the number of sides of our polygon. So in this one here, the sum of angles is going to be 24 minus 2, which is 22, times 180, which will be, if I get my calculator, I think it was 3,960. So therefore one interior angle is going to be 3,960 divided by 24, because it is actually 24 sides, which should give us 165 degrees. So both methods perfectly fine, both valid. When we're testing to see whether prove that triangles are congruent, there are 4 rules we need to know. They either have all 3 sides the same length, or 2 sides and an angle between are the same, so SAS, or 2 angles and the side in between are the same, or right angled triangles, both right angle with the same hypotenuse and a common side. So 4 rules for congruency. Now if we look here, I can see in triangle P the missing angle is going to be 180 minus the sum of 66 and 34, which will give me 80 degrees. So I know that this missing angle here is 80 degrees. Now we've been told that these triangles are congruent, therefore, so if they're both congruent, then we know that x must equal 15 centimetres. So we know that that must be 15. So that will then tell me what this angle is. So that angle therefore must be, so 1580, so that one must be 34 degrees using ASA, and which means that Z must be equal to 66 degrees because the other angle, so using ASA, other angle was 34, and angles in a triangle equal 180. Have a sum of 180 degrees. So that gives me Z equals 66 degrees. So that there is 66 degrees. Therefore, I can work out what Y is. So using 66 and 34, so using ASA, that means that Y must equal 16 centimetres. So I've worked out my X, I've worked out my Y, and I've worked out my Z. Make sure you're confident with all these rules, and make sure you always give a full reason when you are proving them. You must state everything, which rules you're using and why. Now PQRS is a rhombus. So in a rhombus has 4 equal sides and the opposite angles are equal. So 67, 67. So therefore angle P must equal 67 degrees because opposite angles in a rhombus are equal. And work out the size of angle Q. So if P equals 67 degrees, then we know that the angles in a quadrilateral add up to 360. So 67 times 2 will give 134 degrees. So therefore 360 minus 134 degrees will give 226 degrees. So angle Q equals 226 divided by 2, which equals 113 degrees. You might like to pause the video now and have a go at answering these questions. So in these questions we're using the main rules with parallel lines that we know. So we know that alternate angles are equal, or Z angles, but you must use the proper terminology. So alternate angles are equal. We have corresponding angles, we used to call them F angles. So corresponding angles are equal. We have interior, co-interior, sometimes supplementary angles. They have a sum of 180 degrees. And vertically opposite angles are equal. So just the main ones you should be familiar with. There are others. So if we look at this question, if you can draw an F or a Z round an angle and an unknown angle using the parallel line. So if I use this one here, I can draw a Z round 54 and D. So therefore I can say D must equal 54 degrees because it's an alternate angle with 54. And looking at B, to work out B, I can draw an F round 98 and the B. So B must equal 98 degrees because it is corresponding. Make sure you give a reason, make sure you're confident with these ones and use the correct terminology at all times. So you can pause this and have a go at answering the questions and then check to see whether you got them right. Now you need to make sure you're familiar with all the properties of quadrilateral, the different types of quadrilateral. There's only a few here, there are others, and there are other properties you must make sure you're familiar with before your exams. So first of all, I'll briefly go through the ones here. So we have a trapezium. So you could have a trapezium, a right-angled one here. A trapezium is any quadrilateral with just one pair of parallel sides. You could have an isosceles trapezium. Again, we have one pair of parallel sides. Those angles are equal, and these two angles at the bottom are equal. Only if it's isosceles. They will tell you in a question, and it has one line of symmetry. The next shape we have is a kite. So a kite has two shorter sides, each one of those is equal to each other, and two longer sides, and those two are equal. A kite has one line of symmetry going down the middle, and it's got one pair of equal angles. And I would also say here at this point that the diagonals will bisect each other, and they bisect each other at right angles there. Now a square, you should all know about a square. So a square, four sides, do the best I can here, are equal. That's not very good. I must try that again. It's going to annoy me. So four sides are equal in length, have four right angles, rotational symmetry order 4. We have diagonals bisect each other like that, and we have a rhombus, which is a bit like a squashed-in square. All four sides are the same. Pair of opposite angles are equal, so two pairs of equal angles, and all four sides the same length. Put the little dashes on, and also the diagonals will bisect each other at right angles. And finally, we have a rectangle. So rectangle of opposite sides are equal in length, has four right angles, rotational symmetry order 4. It's got two lines of symmetry, the vertical and the horizontal, and the diagonals will bisect each other but not at right angles. So if we read this question, we can use our diagrams to help us answer them. So for each of these descriptions below defines one of these quadrilaterals. For each description, write the correct quadrilateral from the list. All the sides of this quadrilateral are the same length, so that means it's going to be a square or a rhombus. The angles of the quadrilateral are not right angles, so our answer is going to be a rhombus. The diagonals of this quadrilateral cross at 90 degrees. So the only one that does that actually is a kite, and it has only one pair of opposite angles. So there, looking at having gone through our diagrams already, that leaves us with a kite. Like I said before, go through the quadrilaterals, all the properties in chapter 3. Make sure you are familiar with all of them. I've just gone through a few of them here. There are others that you need to know. Here's another question looking at similar triangles. So you could read through the question, pause this video and have a go at answering, and then see if you've got it right. I would just draw your attention to the fact that these questions do tell you that they are not drawn accurately, so don't just measure them. You've got to use your understanding of similar shapes and all the properties of similar shapes to answer them, giving reasons as you go through. So pause the video now before I carry on. Right, the way I usually answer these questions is I would draw out the two triangles ABC and ADE separately, and write down what I know about them. So I have angle ABC and I have angle ADE. Just little sketches, don't have to be masterpieces by any, why not, by any stretch of the imagination. So here we have A, made a mistake there, it's actually ADE. And now I'm going to mark on what I know. So AB we were told is 3 centimetres. DE we're told is 12 centimetres. And AD, if we look at this diagram here, AD is 5 plus 3, so we know that that is 8 centimetres. And we've been asked to calculate the length of BC, which I'll call X. So I want to work out the scale factor, which takes me to there. So that would be multiplying by 3 over 8. So to work out BC, I would do 12. So I'd say BC will equal 12 multiplied by 3 over 8. So working through that, and I always imagine we're doing a non-calculator paper here. So divide both by 4, so that will give me 2, that will give me 3, and so 3, when we're multiplying fractions, multiply the numerators, 3 3s are 9, and 1 times 2 is 2. So your answer would be 9 over 2, or 4.5. Show all your working out and have a go at some more questions from chapter 3 to make sure you are familiar. This is just one example. There are others there in the chapter that you could do just to make sure you understand it before you do the online test. Now in this question there are two ways of doing it. You could work out, well I'm going to work out what the interior angle of a hexagon is. So I'm going to work out what A is. Work out the interior angle of a pentagon is, add them together and subtract from 360 the angles of a point. So if I look at the interior angle of a hexagon, so if we look at, that's meant to be an N, interior angle of a hexagon, so there are 6 sides, so the sum of interior angles is going to be N minus 2 over 180. So N minus 2 multiplied by 180. But I only want one of them, so I'm going to divide that by 6. So that would give me 4 times 180 divided by 6. So if we were to work that out, that would give me 6 into 180 is 30. 30 times 4 is 120 degrees. So I know that one angle of a hexagon is 120 degrees. So the interior angle of a pentagon if we look at that, to work out the interior angle, well the sum of all interior angles is N minus 2 times 180. But I only want one angle of a pentagon, so I'm going to divide that by 5. So pentagon has 5 sides, 5 minus 2 is 3. So that's 3 times 180 divided by 5 will give me the answer. So that will give 108 degrees. So therefore 120 plus 108 will give me 228 degrees. So therefore X will equal 360 minus 228 degrees. So X equals 132 degrees. and we have proved it. If triangles are similar, then all three angles will be the same. Corresponding angles will be equal. So if you, one way of thinking about it is if you had two squares, all angles are 90 degrees, but you could have different size squares. It just means one is an enlargement of the other. They've got the same angles, they're all 90 degrees, one is just an enlargement of the other. So if we think about this shape, we want to prove that all corresponding angles are equal to each other. So we're going on to prove that they are similar. So I can see from here, I can say that angle ABD that's that angle there, equals angle BDE because they're alternate. They're alternate angles. Similarly, I can say that angle ABAE is equal to angle AED. Again, because they're alternate angles. And angle ACB is equal to DCB. They're vertically opposite. So therefore, the two triangles are similar. Meaning that one is an enlargement of the other. Now, if one is an enlargement of the other, we have been asked to work out for part B, calculate the length of CE. So CE, I'm going to call X there. So we've got a scale, our scale factor here, if one's an enlargement of the other, so our scale factor is we're going to multiply by 7/4. Therefore, CE is, or X, is going to be 6 times 7/4. And 6 times 7/4 is 10.5. I've got rubber on. 10.5. Have a go at some more questions like these. These ones are really common in exams, so they come up all the time. And to get all the marks, you must give clear reasons and be methodical in how you lay things out. You must write everything down. And I personally find it easier by drawing the two triangles out separately, but you must make sure you get things in the right order, label things correctly. So here CB comes on this side is CB, so check all the lengths in your new drawn out shape correspond with the original question. Right, in this question it says in the diagram the lines AB and CD are parallel and equal in length. AD and BC intersect at X. So AB, AD and BC intersect at X. And we're told that AB and CD are parallel and equal in length. So I'm going to put those little equal lines there. And CD, so they're also equal to each other. Prove that the triangles ABX and CDX are congruent. So we've got to prove that they're exactly the same as each other. So from here I can see that angle B must equal angle C. So those two angles are equal to each other. So angle ABC equals angle BCD because they're alternate. I've got another pair of alternate angles, so I can also say that angle BAD equals angle ADC. Again, because they're alternate angles. Okay, so we've got two triangles and we've got two equals, and we've also been told that the length AB equals at length CD. So therefore we can say that triangle ABX is equal to triangle XCD because they've got two angles, corresponding angles, and the side in between are equal. Again, pause the video, have a go at the question, and see how you get on. Right, we've got the diagram shows the location of three towns PQR and Q is due east of P. Write down the bearing of Q from P. Now the main points about bearings here are that you draw a north line at the point you're going from. So we always have a north line at the point you're going from. I'll just write this up here, you're going from. Really important. And you measure the clockwise angle from the north line. CW for short. Okay. Right, so we're going right down the bearing of Q from P, so I've underlined from P, so we draw a north line from P. We want the clockwise angle there. We know that Q is actually due east, so the bearing of Q from P is 90 degrees. But you've got to remember we actually want three figure bearings, so we've got to add a 0 in front. So 0, 90 degrees. So to work out the bearing of R from Q, we're going from Q. So I've drawn a north line at Q and we want to measure this clockwise angle. Now using a protractor I measured that angle there to be 140 degrees. So the bearing of R from Q is going to be 360 minus 140, so 260. So that'll give me 220 degrees. So travel on a bearing of 220 degrees. Then for part C, work out the bearing of P from R. So we want the bearing of P from R. So going from R, draw a north line at R, and that is the angle that we want there. So this interior angle here, if I measure that angle there, I've measured it and that's 70 degrees. So the bearing of P from R is going to be 360 degrees minus 70 degrees, which is going to give you 290 degrees. Now I would suggest you have a look at some of the questions from your textbook. They're probably going to be a little bit more tricky than this. We were allowed to use a protractor for this, but you had to show all your working out. But you could also use the properties you know for parallel lines and looking for alternate angles and corresponding angles, and you can extend size of your triangle. So the questions that you at the upper level, to get the grade 8s or grade 9s, you're going to be looking at the more complicated questions. So make sure you go through the questions in the textbook, in the review, and you have a look at some of the questions from the assessment. I would like you to do those before you actually do the online skills test from Caboodle. So I will be setting work on Insight for you to do, and I will choose some questions, and I would like to see evidence of them being completed before you do the skills test. Don't rush in and do it. Okay, well, they're the basic principles covered in chapter 3, and like I said, it's down to you to go back and make sure that you understand them using the resources available.